Here for our school visits. Number one, here's the first. I actually was with a few of these students last year. And what's exciting about this year is now that we're live doing these school visits, these kids are not going to be completely bored with me repeating what I did last year. We have some brand new stuff that we're going to be sharing with them. And today we're going to talk about what makes our weather. And this is geared to a little older students, since we have some sixth graders in here, and you're going to help me with demonstrations. Are you guys ready to go? Yeah! Okay, here we go. Let's start. First of all, we asked a simple question. What makes our weather? We have days like last Saturday where in the Woodlands it's pouring in the morning. We have days like last summer where it's 109 degrees in the Woodlands for 3 times in the summertime, and the ground is cracking and we're in a drought. And of course, here's a shot of the rain. So our weather is changing. We're going from hot, rain, and of course now in the wintertime, we're either cool or we're cold, or on a day like today, this afternoon is going to be really, really nice and mild. But it all starts with the sun. That's where we get our weather from. If we didn't have mild, but it all starts with the sun. That's where we get our weather from. If we didn't have the sun, and if we didn't have an atmosphere, we would not have any weather. But it starts with the sun. So first of all, the sun is 100 times bigger than the earth. The sun is 93 million miles away from us. It takes 8 minutes and 20 seconds for the light from the sun to reach us, which means we're always walking around in old light. So the sun, when we go outside and it hits us, that sunshine took 8 minutes and 20 seconds to get here, and when the sun sets, it actually, when you see that last little sliver of sun go down, that sunshine has actually been gone for how long? 8 minutes and 20 seconds. So we're always walking around in old light. But we get heat from the sun. The heat from the sun comes through us through a process called electromagnetic radiation. Electromagnetic radiation we cannot see, but we feel it. So if everybody can look right here, do you see how that is perfectly still? Yes. When we add heat from the sun, what happens is this starts to turn. So when we go outside on a sunny day, we feel electromagnetic radiation. That's what warms us up outside. And so what this light is doing is it's representing the heat from the sun. It's invisible, electromagnetic radiation. And now what you're seeing is a churning. And if we were to go outside on a really hot day, this thing would spin like crazy. But when it's dark out, it gets cool, and this ultimately either slows down or stops. It's still going because it still has a little bit of heat left over. So does everyone understand electromagnetic radiation? So atoms carry heat, particles all around us. We warm up, that heat energy is released. This is called a radiometer, by the way, and so that's what's representing the electromagnetic radiation. We also get visible light from the sun. We can see the visible light, so it gives us lighting to everything. This is called a halo around the sun, but this is visible light. Let's see, okay. Now we're going to talk about, this is where I need my 4 students to help me here. Okay, so I'm going to do 2 in each group, and then you're going to go with the teacher. So let's go right here, come on up. Right here, come on up, get close to me. Right here, come on up. And then right here, come with me, and you're going to come with the teacher. So what we have are UV beads. So what I want you to do, everyone follow me. And I don't know which, who's the teacher is going to take them out. Okay, right here. Okay, all right. You're going to hold these, and you're just going to go out. And again, I don't know if there's sunshine outside right now, but there's going to be enough that I want you to report back to me and tell me what's going on with these. Okay? You get one. You get one. You get one. You get one. Okay. You're going to go out just a couple minutes, just 2 minutes, and then come back in. For the rest of you, I'm going to show what's happening. Okay? So we're going to come over here. What color is this right now? White. I'm going to put this right here like that for just a couple of seconds. So what's happening with UV radiation, this is also invisible. We don't see it. Just like electromagnetic radiation, we do not see UV light. UV light is really dangerous. UV light, if we don't take care of our skin as we grow up, UV light eventually can cause problems with your skin. Because, again, it's radiation, and radiation is bad. So, what color are these now? Can you see what color they are? I don't know because you're being kind of guided toward it. I'm going to see if I move it away. What color? It's are you guys too far away? So our TV audience can see that these are purple and bluish colors. So now what we're going to do is we're going to interview our friends and see what they see. So let's see, where's the mic, the extra mic? On the table. Okay, so they should be coming in any second now. So what we have in our atmosphere is that all of our weather occurs from the ground where we are to the troposphere. So that goes up a few hundred to 1,000 feet. After the troposphere is the stratosphere. After the stratosphere is the mesosphere. After the mesosphere is the thermosphere. So those are the levels of our atmosphere. Okay, what happened? Oh, they're still colored. Oh, what happened?
Yeah, so when the sun hit it, it would turn color.
Show everybody your colors because they couldn't really see it. So what colors are they?
They're purple, pink, and some of it clearish.
So these are UV beads, and so what's the sun doing to them, do you think?
Changing the color.
Yeah?
The UV rays.
Yes. Did you see the UV rays outside? Did they oh my gosh, I can see them?
No.
You couldn't see them. But you could tell something was happening because?
Because they turned colors.
Yes. So, come back over here. Good job, you guys. Give them a big round of applause. So our atmosphere blocks out go ahead and have a seat, most dangerous UV light, which is a good thing. And then also, how many people's parents or grandparents or teachers have been told to put on sunblock? So I have sunblock right here. We have sunblock from KPRC too. The reason you put on sunblock is because sunblock also protects you from dangerous UV light. So let's see, who helped me? So we'll give you an extra little sunblock there. Okay, so does everyone understand how the atmosphere blocks out a lot of the dangerous UV rays? But our atmosphere is really thin and it's really delicate. And so back in the 1970s, there was a lot of hairsprays, but Aquanet was one of them. And when you sprayed your hair to get them to have your great 80s look or your 70s look and your hair was like this, especially for your teachers, they would have had big hair back in the 70s and the 80s, that actually damaged the atmosphere. And so they actually came up with a way hey, we need to stop this so we can heal our atmosphere because we were losing a lot of our delicate atmosphere that blocked out dangerous UV light. Okay, let's talk about other types of heat now. Conduction. Conduction is the transfer of heat through direct contact. So let me give you an example. Stand on up. So, if I am a flame and I'm on fire and I touch him, what are you going to feel?
Heat.
What are you feeling right now?
Cold.
My hands are cold. My hands get cold really easy. But you are warming up my hand. So by conduction, heat through contact, he is warming up my hand. This hand, how warm is that hand? Now. Warm. How warm is this hand?
Cold.
Yes. He warmed me up. So does everyone understand conduction? So I need 4 more people to help me. 4 new people. Let's do, who did I not get? Okay, 1, 2, 3, and then, well, we already had you, so come on up. Yes, come on up, quick. We are going to explain conduction. Remember, conduction is heat through contact. Okay, so, what's your name?
Caden.
Caden, everyone say hi to Caden.
Hi, Caden.
What's your name?
Jade.
Jade, everyone say hi to Jade.
Hi, Jade.
Okay, what's your name?
Joseph.
Joseph, everyone say hi to Joseph. Hi, Joseph. We have Taylor Swift, everybody! What's your name?
Matilda.
I'm sorry?
Matilda.
Matilda. Oh my gosh, what a unique name. That's so pretty. Okay, we are going to demonstrate conduction. So what we have are what are called hand boilers. So you warmed my hand. Now what you're going to do with your warm hands is you are going to show how not only conduction works, but also how lift works. So everyone, you guys are going to put your hands like this. I'm going to put something in your hand, and then I want you to cup it. I want you to cover it as much as you can and not drop it. Got it? Okay. Let's see. You got orange on, so I'm going to give you red. I'm going to give you purple for Taylor Swift. Great. We got purple haze. We have blue and green. Everybody watch very carefully. Well, I'll get there. Blue and green. Everyone watch very carefully. What's going on with the water? It's rising. Look at it. It's boiling on it. Boy, how warm are his hands? Does everybody see how the water is rising? So I'm going to take Matilda's, and so it goes back down because of her warm hands. So because of her warm hands, let it go all the way back down. There it goes very slowly. Matilda and her Taylor Swift sweatshirt are going to now what? Make it go back up. So the warmth of her hands is heating and it's lifting. That is conduction. Does everyone understand conduction? Yes. Give them a big round of applause. Great job. Okay, you guys have a seat. Now, we're going to talk about convection. So conduction is touch. Convection is heat created through liquid and gases. So this is tough to see. So first, let me see if I can show you this. Hopefully I didn't press anything wrong. Okay, so if I did, so I pressed the play button, so it went to black. So what happened? How do I get it back? Let's see. Oh, it's not playing. Okay, so we're going to close that and see if that gets... Okay, so what you were going to see, it didn't work for some reason, but what you would have seen is you would have seen evaporation. You would have seen water that's on this pillow, and you would have seen gas come up. So we're going to watch this cloud now. On a sunny day, or a day like today, well, you know what's a good example? Tomorrow and Friday. What happens is the sun heats the Earth's surface. You start to see clouds build, convection, and then you start to see condensation. So what's happening is you're getting convection, the cloud is building up, and it gets so heavy that now it starts to rain, and it can, especially like on Saturday and Sunday, it can start to get thunderstorms. So the sun heats the earth, air heats up and rises, clouds condense, and rain and storms form. There's high and low pressure. Wind travels from high pressure to low pressure. So I'm going to create some wind here. Watch this. What's happening to her hair? It's moving a little bit. Can anyone see the wind? No one can see the wind, but you can see her hair move. So if I'm high pressure, she's at low pressure, wind moves this way. Wind does not move this way. Wind never moves from low pressure to high pressure. It always moves from high to low pressure. So if you ever want to know which way wind direction is going, if you ever were to look at a map with high and low pressure, you can tell which direction the wind is going to go because that's how it blows. But air pressure is the weight of a column above the surface. So to give this example again, when we did this, everything came up because you have low pressure lifting. It's very light. High pressure is very heavy. So high pressure sinks the air. So the last couple of days, we've had a very strong area of high pressure over us. And so what color were the skies? They were clear. It was blue. It was gorgeous. But today, you're going to start to see clouds come in today and tomorrow because now low pressure is lifting all the moisture that's on the ground. It's condensing, and it is becoming clouds. So does everyone understand high pressure is heavy, low pressure is light? We don't feel it either. So high pressure has weight, but we don't feel it. Low pressure is light, but we don't feel that either. But the weather does, and so you get lifting in clouds, you get sinking in clear skies. We mentioned, I just said this, and somebody said, I said, what color is the sky? I said, what did the skies look like, or clear or something, and someone said they were blue. However we said that. But why is our sky blue? All the colors of the atmosphere actually all the colors of the spectrum actually hit our atmosphere, but blue is the only color that makes it through. So if we had different eyes, we would see every color outside during the day. But what happens is our atmosphere, and we talked about the atmosphere a little bit ago, blocks out every color except blue. So the reason it was so clear and blue yesterday was because all the colors of the spectrum were blocked out by our atmosphere, and the only one allowed in was blue. But the color blue has a short wavelength, so it scatters really easy, and so it's easy to see. But here's the question then, why on sunrise and sunset, and this morning sunrise, if you saw it, was just beautiful, why do we see red, yellows, orange, and even purples? Because when the sun is low on the horizon, either coming up or going down, those colors start to show up because they travel farther. So blue is short, and so you're far away now. The sun is far away, setting or rising, and so now these are the colors that are coming up. So here's how I forecast the weather. Oh, you know what? Let me do this. I need someone else to help me with something. I forgot we need to demonstrate low pressure. I need somebody strong. Come on up. Yep. Here's what I need you to do. Okay, first of all, how good are your eyes? Can you see the number that's there? Can you see what temperature? Tell me. Oh, let me get your. Okay, first of all, what's your name?
Avery.
Avery, everyone say hi to Avery. Okay, Avery, come in the middle so everyone can see you. Avery, tell me what temperature you see in there. It's in Celsius, so it's going to be not familiar.
I see 18.
18. Okay. All right. Avery, you ready to do this? So this is why I need Avery's strength. I just need you to pump up the bottle. And what you're going to do, hold it with both hands. You got it? I'm going to let you do it. Do it. Use all your strength. Use it until you feel like, man, this is not going to let me go. So we're going to demonstrate low pressure. And we're going to demonstrate low pressure and how it lifts. So we're adding heat in there, just like the hand warmer. So when you add heat, you're getting low pressure. What should happen to the water that's in there? Did you get it pretty much? You got it pretty good? Oh yeah, you did a great job. Tell me what the temperature is now. Can you see that?
It's 22.
22. So it went from 18 degrees Celsius to 22 degrees Celsius. So how much warmer did it get in here? 4. 4 degrees, right? 18 to 22, 4? Okay. What should happen now? What we put in real drops of water. What should happen? Do you see that? Did you see how it became a cloud in there? So there's no more water in here. Did she kill the water? No. She didn't kill the water. So I'm going to put 2 drops of rain. You do it too. Put your hand out. Okay, ready? We're going to do something. We're going to rub our hands together, creating heat. Okay? Now, let's get the water to fall to the ground, okay? Why did the water not fall to the ground?
Because the heat absorbed it. Because the heat absorbed it.
Okay? It evaporated. So what happened is we didn't kill the water, we didn't make it disappear, but it changed phase. So it went from liquid into invisible gas. And so now it's floating around here somewhere, and eventually it's going to get outside, and it's going to keep climbing, and it's going to become a cloud, and eventually it's going to come back down again as water, rain. It could be snow, it could be hail too, but that's how it's going to come down. Okay, good job. Okay, we're going to talk about how I forecast the weather. Renee gave me a 10-minute cue, and so I think we're a little less than that now. So at work, let me make sure I did all the demonstrations. Do we got everything? Good. We got wind, we got light, we did everything. Well, you guys got everything. That's great. How I forecast the weather. First of all, I look at radar. So on a day like tomorrow and Friday, I'll know where it's raining and whether it's raining in the woodlands or not. I have satellite images, so I know where snow is falling and I know where the clouds are. I have radar for hook echoes. That hook that you're seeing there, those are bad because that would be a tornado. Or at least a radar-indicated tornado. And I have recording stations. So at your school, if you have a recording station that will show me the pressure, the winds, and the temperature, that's how I know what's going on in the woodlands. I have surface maps. Can you guys see what that is? What is that letter? H stands for? Are there any clouds around that high pressure? No. Because high pressure air is heavy. So it sinks, and it's really hard for clouds to build up. Do you see all the low pressure areas? What's around the low pressure areas? Clouds or rain. you have weather models that actually go out in time and show where high and low pressures move and where rain moves. And I also look outside. So if the rock is wet, it's raining. If the rock is swaying, it's windy. If the rock is hot, it's sunny. If the rock is cool, it's overcast. If the rock is white, it's snowing. If the rock is blue, it's cold. If the rock is gone, tornado. So you have to use the science, and there's also a little bit of art with that. And then I have to make the graphics. So a cool part of my job is I get to create the weather story, or what the essential message is, and then I present that to you on TV. So this is how I do my job. We were practicing a little bit ago with the kids who were going to do the weather live, and when we were showing them that, and I said, whatever you do, don't move to the right, because that's what your mind is going to want to do. Because when you brush your teeth in front of a if you brush your teeth in front of a mirror, your toothbrush is over here, right? If you brush your teeth on TV, your toothbrush is over here. So the hardest part about this job, and if you ever get the chance to do it, is that your inclination is you want to move here to show temperatures are over here, but the temperatures are actually over here because you're flipped. So anyway, that's how I do my job when there's a green screen. And a lot of shots also don't use green screens. But that's how I do it when there is a green screen. Okay? I can't wear green. Why can't I wear green? Yep. So I showed this picture last year. I think you guys saw this. I think for one Halloween, I wore green, sort of. But I only covered my head. So for Halloween, I went as, on TV, the Headless Weatherman. Because I covered my head, and whatever my head is will be the same thing as the screen, so it's showing the maps all the way through. But that's what happened there. And then let's see, I think we established that videos don't work here, but I would have showed you what it looked like, and it doesn't work. There is a video, but it's not playing. Oh, and this probably is not playing. Can I tell you what question? I've gone to every school this year, and you know what the number one question is always? How does a tsunami form? Oh, it's weird. I mean, kindergartners, first graders, all the way to sixth graders. Always this question. Okay, we're going to try this again and see if it works. Let's see. Oh, okay. So the way a tsunami forms. First of all, there's an earthquake that occurs out in the Pacific Ocean. It can be other oceans, but I'm just giving the Pacific Ocean as an example. The entire column of water is forced up at that point. But it goes across the ocean as a shallow wave. If you're on a boat, you're not even going to notice it. But once it gets to the shelf, the water is forced by the seafloor up. Water recedes from the coastline, so if you're on the beach, water goes away from you, which is a bad sign, and then you get the water to come up from a tsunami. And it can go up as far as 1 mile. So I show this because we're going to do this again. Nope, let's skip to the latest play. Cancel. Let's see if we can show this again. I think there's it takes a couple seconds. Maybe we won't show it again, it'll just show up. Oh yeah, see now it's not doing it. But that's the number one question we always get. Can we get a tsunami in the Gulf of Mexico? What do you think? We have mixes. Raise your hand if you say yes, we can get a tsunami from an earthquake in the Gulf of Mexico. Good. Raise your hand if you say no, that we cannot get a tsunami from the Gulf of Mexico. Not everybody raised their hand. We cannot get a tsunami in the Gulf of Mexico from an earthquake because the Gulf of Mexico is just a big giant hole. There's no fault lines whatsoever. In the Pacific Ocean, there's what's called the Ring of Fire, and there are earthquakes there all the time. The only way we could get a tsunami, and this would be bad, by the way, is if a meteorite a large one hit the Gulf of Mexico, and that would create a massive tsunami. That's the only way we can get it. And by the way, if that happened, we would have much bigger problems besides just the tsunami. But just so you guys know. And I put that there just because a lot of kids have asked that. Okay, you guys are 4th, 5th, and 6th graders. So I have another question to ask you. Geography and weather. We got 3 minutes left. What is this a picture of? Who's confident? A volcano. I hear volcano. If you're confident, come on up and tell me. You can tell me. Not a volcano. Come on up if you know. Yes.
Low pressure affecting a cloud?
Low pressure affecting a cloud? No. But great guess. Yes.
Wind.
Wind. Yes. But there's more. There's more than just wind. Anyone else want to take a stab at this? Yes.
Tornado.
A tornado. Good guess, but not a tornado. A hurricane. Good guess, but not a hurricane.
An earthquake.
Earthquake. Good guess. Okay, we have wind and we have geography right. One last guess, and I'll tell you.
Rain.
Rain. Good guess, but not rain. Okay. If it's a fault line, you can't see the fault line. So yes, go ahead and shout it out. Clouds. Ready? Is everyone ready for the unveiling? Smoke. You are looking at Southern California. These are what are, first of all, the winds are Santa Ana winds. So winds race down the mountains, just like a bike. Like if you're on a bike with no brakes and going downhill, that's how fast they go. It warms and it dries. It pulls moisture out of the trees and plants. Now, wind's invisible, right? We established that. You can't see wind. What you're seeing, and it's tough to see from your view, but there are little tiny red dots all around here. You actually are looking at 1, 2, 3, 4, 5, 6, 7 different fires. And so what's happening is the winds are taking all the smoke from the fires and it's blowing it out over the Pacific Ocean. So winds, fire, and smoke. Let me see. I don't think I have time to get to the next thing, so I think we're about to run out of time. Oh, 1 minute. Let me just see what we have, and then we're going to say goodbye. Is that good? Let's see. Rain and flooding. Okay. Who has one question that can be a short question that I can answer, and then everybody can say goodbye? Let's see. Come on up, real quick. Yep. Yep, you got to come up. Yep, we've got 1 minute left. Is everybody ready to wave goodbye? You guys are all ready? No, you're not ready. Okay, what's your name?
Kaylee.
Kaylee, what's your question?
Can I have an autograph?
Yes, you can have an honor. And you know what? That took like 0 time. So that was easy. Okay. Anyone else have a different question that can take 30 seconds or less? Come on up. Okay. What's your question?
How long did it take for you to go to college and do your job?
Oh my gosh, that's a great question. It takes, well, if you go to college and you go for geoscience, which is a meteorology degree, it takes 4 years. It took me 3 years to do it because I already went to college, so I got a meteorology certificate, and then I had to get my seal, so you have to be certified. Like a doctor, when you go to a doctor's office or a dentist's office, you got to make sure they're certified, right? Everybody say goodbye!